Hello? 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 Shh. If you'd prefer, I can yell good afternoon, Matthew Day, but I think I'll save all of our voices. Okay, hello? 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 Shh. It's good to see you all again. Hello, everybody. Apologies, I haven't been here. If I start coughing badly during the lecture, I'll try not to cough into the microphone, so I'll do my best. But otherwise, it's good to see you all again. I hope you've had a good quiet week and mid-sem break. No, that was a while ago. Good quiet week. So for today's lecture, we're going to be looking more at pointers, structs, and malloc, and some assignment stuff. So I've got everything set up. The tablet has unfortunately run out of battery, so I'm going to try and use the document camera. We will see how that goes. Shh. Shh. If I say it more forcefully, will you be more quiet? So after today's lecture, there's a long list of things here. You should be able to make more progress on assignment 2. How many of you have started assignment 2 and written any code at all? Okay. How many of you have written any code other than the player name function? About half. That's good. How many of you are really confused and you don't know what's going on and you're like, what is going on? How do I do this? Cool. Well, good news for you. You won't feel like that after the lecture if you stick around and pay attention. So, shh. We'll talk about that. We're going to look more at pointers because I know pointers are confusing for everybody. What they are, how to use them, why we use them, which is a big... If you don't know why we use them, you're not going to want to use them. We are going to look more at structs, because everybody is confused about structs still. We're going to look more at memories, so malloc, and the difference between. Okay. So some admin stuff. Don't panic. So shh. Shh. How many of you were new to programming at the start of the semester? You've done either a tiny bit of programming or none at all. Okay, leave your hand up if you're still confused. No, other way around. Leave your hand up if you're not as panicky and confused and life is sort of okay with programming. Okay, that's not super heaps of you. Learning programming is hard. You can't just decide, shh. You can't just go the night before the exam, oh, I'm going to learn programming overnight. It's not like that. It's not a thing you can just cram for. It takes constant, persistent effort, a little bit every week, keep on going, and then you will get there, you'll learn to program. So the fact that you are here, you've shown up to the lectures, it's a great first step. And we will get you to be good programmers who don't panic by the end of the course. So, I hope. Assignment 2, if you haven't started yet, start ASAP. I can't stress this enough, you can't just do the assignment overnight. We've extended the deadline to Sunday, the 13th of May, which I think is the week after it was already. On the basis that there's a lot of cool things you can do in the assignment, and so we want to give you enough time to do cool things. Assignment 1 marking is with your tutors now, so they will be giving you feedback over the next days as they mark the stuff. The week 8 weekly test is due tomorrow. How many of you have done the weekly tests? Okay, how many of you have managed to solve at least the first question for all of those tests? For the assignment, or for in general? Why would you need it? Okay, the question was, can we use a thing that we haven't covered in lectures that's in the standard library of C? Yeah, sure, go ahead, unless we say you can't. Shh. But with the weekly tests, if you've been able to solve the first question each week, then you're going to pass the course. Good work. If you haven't been able to solve the first question, then you really need to think carefully, do as much revision as you can, try and learn as much as you can. Shh. Why are you all talking so much? Is it like a competition to see who can talk loudest? Because I have a microphone, I'm going to win. But let's not do that. And don't forget about the help sessions. There are more running because of the assignment, so go to those. It'll be super great. Okay, let's talk about pointers. Let's talk slowly. And I had all these great diagrams I was going to draw. The tablet is up to 5% battery, so maybe in the second half. But before we talk about pointers, let's take a step back. That's the button. So if you think back to week 1, right, if we say int age equals 16, what does this actually mean? And let me try and document camera. Okay, can you see this piece of paper? Yes, you can. Does this pen work? Okay, let me know if it's gone off the screen or if I bump it or something. So if you think back to week 1, int age equals 16, what does this mean? Someone, what does it mean when we say int something equals something? Nobody knows what ints are. Have you all forgotten everything since you were here last week? What's an int? It's a type. What are types? The variables. So when I say int age equals 16, I mean here's a box. It will hold an int. It's called age. It has 16 in it. Yep. So this is that too small? Is it a good height or is it too small? Okay. I'll just write it bigger rather than trying to push a button. Is that a good size? Cool. Cool. So thinking then about functions. When we have a function, we know that there is memory for that function because it has to be able to put its variables somewhere, right? And so if I have my function main, main void, you can just pretend that you can read my handwriting. So what this means is main has some memory for it, and this is the memory for the function main. It has its own memory set aside for this function. And inside that memory, we have a box for an int called age, and a box for an int called height. 16, 1, 85. Assuming you can read my writing, is this all good so far? Functions have memory for that function only, and inside that memory is the variables of that function. Is this good so far? Everyone remembers like week 1 and 2. Cool. So arrays then. Arrays are just a bunch of variables glued together, right? So int array size means we have an array of size ints all glued together. So if we pretend that I drew the box bigger, because I thought about this in advance, I said size was 5. Is that still sort of readable? I might try and make it bigger. Zoom. Whoa, help. Computers are really hard, okay. Oh, what are you doing? Does anyone know how to work this? A couple of times, cool, cool. Okay, I'm gonna leave it there. Not gonna try and make it any bigger. So when we have an array, we have a whole bunch of boxes glued together of type int, and we can put numbers in them. So we can say like, we've got our int array size, and we can say like array 0 equals 10. Right, this is all good so far, so I can put the number 10 in here. Cool. And so because the variables are in memory, they have an address somewhere, like they exist in a place in memory. They exist in a place in memory, and we have an address for that. We can say it's in this spot here of memory. There's like the full range of addresses is at this specific spot here. So I'm going to make some numbers up for addresses. I'll say this is at 0x100, 0x104, 0x108. So these are numbers. The 0x means it's in hexadecimal. So that means it's 0 16s plus 0 16 squareds plus 1 16 cubes for 100. So all good so far. We have memory for our functions. There are things in the memory of those functions, and they have a location. So when I call my function, which I've called foo for great names, right, my function foo has its own memory. I will see if I can fit it here. Int num. C, I think. Cool. So in my memory for foo, I have an int num. So it's in a separate blob of memory for this function foo, but it's still a box of memory that things can go in. When I pass an array, well, no, before I talk about arrays, when I pass a variable into a function, right, if I have a function, I give it an int, can it change the int from the function? Like if I have this function, int I passes I into this function down here can't change the I from this one, right? When we pass a variable, we pass a copy of the value. But you've seen with arrays you can. You can write a function, give it an array, and then it'll be changing that array that we gave it from the other function. And the reason for this is because arrays are actually pointers. We've kind of told you, oh, arrays are arrays, but they're actually pointers. So what that means is that an array is the address of the location in memory where that array is. So for example, when I have array here, when I pass array into the function, it gets the value 0x108. So it gets a variable called array. I'm going to actually write that in there. Sorry, people watching the lecture video, you can just look at the slides at the same time. So my function takes in an array. What it's actually given is a copy of the address of where the array is in the main function. So it's given this 108 here. And so when we access like array element 0, what this means is instead of having its own array in foo, so there's no big array in foo, right? There's no series of boxes. It has the address of the array that's in main. And so when we say set array element 0 of this array called array, that means it actually goes, I have the address of this array in memory. I'm going to go to that address in memory, which is this one up here in the main function. I'm going to go to element 0 of that array, which is this one here. And I'm going to make that be equal to 100. Does that make sense so far? When we have an array, when we pass an array into a function, what we're actually doing is we're telling the function this is where you can find the array. And so when that function changes the array, it's actually going, oh, I know where this array is. It's up here in main's function. I'm going to change the array in main. Does that make sense so far? One person nodded. Thank you. Are there any questions about this so far? Because this is sort of like a key thing you need to understand for the next things. Yes? How does the stack frame fit into this? So each of these squares I've drawn as a stack frame. A stack frame is just a name for the function's memory. You call it a frame. That's sort of a word you can use to mean the memory of a function. It also has other information like this is like the limits of it, but we don't need to know that stuff for this course. Yeah, these blobs of memory for a function are called stack frames. Cool. Is that all good so far? Okay, if I have remembered correctly. So when we pass a pointer into a function, then when we explicitly pass a pointer, because arrays are pointers, we can pass arrays in, and that's all good. We know how to do that. It magically works. Am I talking too fast? Or am I talking okay? That's good. I feel like I'm talking way too fast. Glad I'm doing okay. So when we pass an array into a function, we're already passing a pointer in. We can do that. We didn't know it was a pointer, but we've got that down now. We can also explicitly pass a pointer in. So what that means is, can I point with the mouse? When we have this int star age here, we are saying, give me a variable inside this foo, or a variable that I can access inside foo, of type int star. So the type of this variable is a thing that holds the memory address of an int, and call it age. And so I set up here, my age was at address 100 in main. So when I call foo, I wish I could, on my tablet, resize things and scroll around. Inside here, we also have int star age. Ooh. And so when we give in this function parameter here, we're passing it in the address of age. We're saying, here's where you can find the variable age. And so that is being given, right, 0x100. It'd be really good if I'd drawn them consistently. But int star age is a box of type int star, holds an address of an int called age. And this contains the value 0x100. So it's got the memory address of where age is up in main. And so this means that we can change the value that's in main from the function foo, because we know how to get to it. And so when we say star age equals 21, the star means go to this address and change something there. So star age equals 21 means go to the address that's held inside age, which we can see is 100. Cool, it's still on the screen. So go to this address 100, which is up over here, and change the value in this. So age with a star, go to the thing that's in the address in age, 0 to 100, change it to be 21. And then this is, computers are way better than I am at drawing. That says 21. Cool. And the reason that this works is because we have told foo where to find the variable age. Foo could just decide to write to this anyway. It could decide, I'm going to guess that it's around this memory address and try writing there and hope for the best. Sometimes it works. Probably won't work. Probably it'll crash. This is why with a pointer we tell you the address of it is here so you can safely write to it. But foo could go, oh, I'm going to write to the variable at address 10,000. If there happens to be a variable there, then we've written to it. Cool, that's great. If we've guessed wrong, then we've broken something in our program or overwritten something in memory. So bad idea to do that. Cool. Does that make sense so far? Is this good? If you are confused about anything here, raise your hand. What are you confused about? Cool, very good question. So in, I wish I could erase things like on my tablet and I'll write it up here. So the question was when I have the ampersand with age up here, so when I call the function foo and I'm giving it a pointer, I'm giving it the address of something, ampersand age means the address of age, whereabouts in memory the variable is located. So in this case, ampersand age is 0x100. Does that make sense? Cool. Any other questions? Or any other confusion? Okay, is that the end of my slides on pointers? I think it might be. Okay, would you like to see some demos of this, or are you happy with the ideas and we can move on to structs? Does anybody want to see code demos of this to understand? Okay, a couple of people. So let's do, because I find pointers are really confusing, and then one day you understand them and they're completely simple. So the trick is trying to have enough different people explain pointers to you until you reach that point of, I understand. Is that a question? So is your question, when you pass an array into a function, you can access any element of that array? Yes, you can. Gedit pointers. Although this one does not mean take the address of something. Okay, hash includes h. So here's the code from before. I guess what I would do, I'll print out these addresses. The address of age is... and so I use %p to mean like a pointer or a memory address. The address of array is the address of array. And then I call my function foo. The value of star age. So what I'm going to print out here, the value of this variable here in star age is some pointer, some memory address. And then let's print out the value of array 0 is cool, and then afterwards I will print the value again. Okay, and so what this is going to do, in main it's going to print out what the address of age is. It's going to make an array, print out the address of that array. Then call this function foo, giving it the array and the address of age. When it gives it the array here, it is actually giving it the address of that array. We just don't put the ampersand there because arrays are already pointers. Everything makes sense if I wave my hands. So then inside foo, I'm going to print out the value of this pointer age, which should be the memory address of this variable, because we've passed in the memory address of the variable. I'm going to... what is %p? That stands for pointer, I think, but it means print a memory address. I could print it out as %d and it'd be a long int, but I can print it as %p to get a hexadecimal number that looks like a memory address should look. And then we're going to print out the value of array 0. I'm going to change the value, then print it out again. If I... oh, man. I've forgotten how terrible it is to try and resize windows. Pointers. And by... oh, do you know what I forgot? I forgot a function prototype. If I had $1 for every time I'd forgotten a function prototype, I could give up teaching. Cool, pointers. And by the way, the code for this, you can access the code as I write it in the place where you could access code before. If you click on in web CMS, then you click on like week whatever's code and go up a couple of times, and then, yep, I can show you in a bit if you want. Cool, and so in pointers, the address of age is this thing here, 0xFFCE77F0. We'll just pay attention to this bit for now, 77F0. The address of array is 7780, so it's a little bit after it in memory. And then inside our function foo here, the value of int star age is this address here, which is the same as the address of age. So we can see the contents of this int, the actual value inside this int is the address of the variable. The value of array 0 is some weird random number. The address of it is this, and then the value of it is 100. What have I done wrong here? Why is it this number? Yeah, I haven't initialized. I didn't copy the code where I set it to 10. Oops, array 0. Oh. And this is an example of what happens if you don't initialize your array. Valgrind will tell you off, but it also means that you get whatever happens to be in memory there. Let's run this again. /pointers. There we go. So the value of array 0 is 10, because we set it up here. And then when we change it down here, we go array 0 equals 100. We've changed the value of this array that was up here in main. Does that make sense? Are there any questions about that? Yes?
Why is line 17 you need to define the array size as the size? How do you just do that blank?
So why do I need to define the size in here as size? That is a good question. I don't know if I've talked explicitly about this, so let me do it right now. There are several different ways we can pass arrays into functions. We can pass in int array square brackets like this. This is a valid way to have a function, and inside this I will have an array. The question is, what size is this array? I don't know unless I know some other way, like nothing is telling me the size. And so I don't know how, like if I'm trying to fill the array, how many things do I fill it with? Who knows? And so conventionally we'll say int length, int array thing, or int size, giving it the length of the array and then the array itself. And this is just so that inside the function we know how many things are in the array. And so then we could have... So is it just readability? It's also, we have to do it, because if I have my array like this, you know, and I equals 0, while I is less than, who knows, array I equals 100. Right, if I'm in a function and I've just been given an array, I don't know how big the array is. How do I go through everything in the array? I don't know how many things there are. So I can either do that by giving it the size, in which case I know, I might copy that. I can either give it the size and then use that. Size. Or I can pass in an array of a fixed size that I know about already. Array size. With a hash defined size. Does that make sense? Cool. Was there another question approximately around there as well? Yep.
Why did you have an ampersand line 9 and then later on you don't have an ampersand?
Where do you mean by later on? Hang on, let me move all these functions away so that we can still see. Line 19? Cool. So when I do the ampersand here, it gives me the memory address of the variable age. So ampersand age is equal to Curtis, do you know how to turn off ASLR for a thing that's like set arch plus, oh, I worked it out. We saw last time whenever we run it again, the address changes, which is really annoying to try and put comments saying what the address is. There's a way you can turn it off, and I've forgotten what it is, but we'll pretend for now that it's this. There's like set arch something.
Oh, CMC.
Yeah, I don't have root.
No, you don't have root.
Just Google for set arch uname -m. So the address of age is this, right? So this is saying the variable age exists in memory at this address here. And this is a big number because the memory is big in computers and not small like on paper. Yes, that's exactly it. Yeah, and then I've got a new terminal. Beautiful. And so with the power of disabling security features, they're now in the same location every time I run it. That was not what I meant to do. Cool. And so ampersand h means the address of this value here in memory. When I have this one here, int star age, I might call it age pointer to make it really clear that it's a different variable. So in here I have a variable called int age pointer now. It is of type int star, which means it's of type holding an array, holding the address of an int. And so I have the ampersand here because I'm telling it this is the address of it. And then I don't have the ampersand here because this is a value. Its value is the address of it. Does that make sense, whoever the person was who asked the question? Cool. You know, that's a good question. And the ampersands and the stars and everything are confusing, and then one day they'll make sense, and it'll be great. So I'll try my best to get you there. Are there any more questions? Okay, let's look at another new and exciting topic. I'm drinking some water to indicate the transition between topics so you can all change your minds. So, no, it's not a break for you to talk, it's a break for me to drink water. So let's look at another thing. We have seen structs already before. We've seen arrays for a long time. Arrays are a collection of many of the same type of variable. So int array 10 means I have 10 boxes that can hold one int, all glued together. So here's giving them the values 0 through 9. Hopefully this is all good so far. We've looked at arrays for quite a while. We can also have structs, which are a collection of many of different types of variables. Maybe just many different types. So when we have a struct, rather than having a series of boxes that will hold ints that are all the same, we have a series of boxes of different kinds. So in this case, I've made a student struct. I've got a field for ZID, which will be an int, which will hold a ZID. I've made a field for name, which is a string. It's a character array of size max namelen. And I've got an int assignment 1 mark, which will hold an assignment 1 mark. And so if we looked at this like in a diagram like we drew with arrays, or just a thing stuck together, this contains one box for an int, one series of boxes for characters, and another box for an int. And at this point, I was going to draw a diagram with a tablet, and I could copy and paste, and it was going to be great, but that's okay, we'll get back to that. So then to actually make a struct, the syntax is, when I make an int, right, I go int I equals 10. When I make a struct, I go struct student Andrew. The type is struct student, or a student struct, and the name of the variable is Andrew. So I can fill out the struct, I can say andrew.zid. The variable is called Andrew. Andrew dot means the field called ZID inside the struct equals some ZID. Andrew.assignment 1 mark equals 94.5. I didn't check for invalid days that were less than 0. So I lost marks. It's terrible. And then I can fill in the name. Because the name is a string, I need to use stir copy or something like that to copy it in. And so stir copy is like saying Andrew.name equals Andrew in speech marks, except it does the copying character by character rather than just setting them to be equal. And that's the same diagram from before. So does this make sense so far, conceptually? Arrays, a whole bunch of the same thing. Structs, a whole bunch of whatever different types of things you want. Is that all good? Cool. And then I can make an array of structs, because you can make arrays of anything you want. So this is of type struct student array called students. So like how we'd say int students, num students to make an int array, we've got struct student, students, the size. And so we can fill out one of the students in the array with like students bracket zeros. Like if we had an array square bracket 0, the thing at position 0, which in this case would be this student struct dot ZID. I really want to draw a diagram. I'll try and draw a diagram on here. Actually, how charged is the tablet? 15%. I'm going to use that for the second half then. So I will draw more diagrams for this in the second half to make it less confusing. But this is saying, of my array of student structs, go to this one of the structs in this array and set this field of it to be this value. And then I can fill in what happened there. So I use Vim as my editor to make my slides, and Vim has all these buttons I don't know about, and sometimes my numbers increase by 1. So I think I might have done that accidentally. These should all be 1. But this is saying student square brackets 1 is the second array element. I can set that ZID to be a different ZID, that mark to be a different mark, because Andrew Taylor didn't consider New Zealand or Broken Hill. Like, come on, New Zealand is not part of Australia. And then stir copy into that name field the word Andrew. So let's do some code for this. Alt-tab. Save as structs.c. What's going on full screen. Oh, it's going to load fast. So if you go to lectures, and then you go to any of the previous Andrew B lecture codes, so like week 2, for example, hit view and browser to make it easy to see. Go parent directory, that's all of the weeks. Go to week 9, choose date live, and that's the code I've been writing, if you want to see the code. So any of the previous weeks of code for mine, hit the parent directory thing, and then the weeks get listed there. Cool. Int main void return 0. Okay. I'll just chuck this code in a function so that it's not in the way. And I'll make another function for just one struct. Cool, done. So looking at the code I had from before, struct student Andrew means make me a new variable called Andrew of type struct student. And then I can fill out the fields of this struct. I'll collapse this so it's smaller to see. So in this struct I have a field ZID, which stores as like one int. In this case, this is my ZID. Char name, which is a series of boxes of characters, which is going to be a string, which I set here to be Andrew, and then the assignment 1 mark, which I set to be equal to a value. Does this make sense so far? This is the syntax that I can use. Yep. Say that again. This word here? Like in here, or? So why is it this? Why is it this rather than this? So the reason... Oh, stir copy, yes, sorry. It's hard to hear. One of my ears is still blocked as well, it's terrible, so I can hear people on this side of the room. So why do we have to use stir copy? You know how I said before that arrays are pointers? And I've also said that strings are just character arrays with a null terminator at the end, so it's just an array, but with a different value inside. If I tried to say some array is equal to Andrew like this, I'm trying to... That's not explained well at all. Let's run it and see, and then I can explain why it didn't work. Structs.c. Hash define. That's not an int. There we go. Cool, now I just have the one error that I want. So the error I'm getting here is saying error array type char50 is not assignable. And what this means, when I have an array, I have a bunch of memory that's been allocated, like the boxes that are all glued together, right? And these are the boxes, in this case of type char, that I can put the name in. When I try to say, like, my array, my string equals Andrew in speech marks, it doesn't know how to do that. It's like trying to say, here are my boxes, that's my array. And then I'm saying that equals Andrew like this. It doesn't understand how to do this. The array is a bunch of like concrete boxes. And this is a string when it's inside speech marks, we'd call it a string literal. You can't change this. So if we had char star name equals Andrew like this, and then we tried to change name 0 to be B, this would not work. When we have the speech marks, it's a thing that we can't change. And so that'd be like trying to say, make these boxes. I'm really not explaining this very well. It doesn't work. You can't do it. It's not a thing that you can do. The way that you need to do it is to copy each element one at a time through. So you need to copy in the A into this, the N into this, the D into this, and so on. Does that answer your question, person with question? Have I satisfactorily not answered your question? Yep.
You do char star name equals Andrew, and then you do Andrew dot name equals name.
So the question is, can I do char star name equals Andrew, and then Andrew dot name equals name? No, I can't, because that's the same problem. That's equivalent to trying to do this. This is effectively the same thing. In this case, we're making the variable name be a pointer to the string, and then that's the same as setting it to be directly equal. Say that again? Was your question, isn't it setting the pointer? I'm not entirely sure I understand your question. Can we talk on the break and then I can explain afterwards, if that's okay? Does not work. Are there any other questions about this thus far? Yep.
You have an array of struts.
Mm-hmm. Say that louder. If you have an array of structs. I don't know. I don't know if that will work. It does? Double squiggles? Okay. Let's look at that after the break when I've played around with it a bit.
Why am I allowed to, when I initialize an array of characters, set it to that why does that work?
What a good question. Let's answer it later. So looking back at the structs, looking back at the structs. So this one here, it does work. I'll fix those typos later. So this one here is making me a struct called Andrew of type student struct, filling in these values. And so now I have this variable in memory rather than like an array of the same type. I've got a series of different types all glued together in this one larger type. And so to prove that it does something, let's write some code. The name is setID. Cool, and so this dot name syntax here, when I'm trying to get the field name from inside the struct, it's like, you know how I can have an array and I can say array 0 is get me the 0th element. It's because they're all ints and they're all together. There's no specific name for each of the individual elements. Whereas in a struct, each of these things, individual things, has its own name. To refer to the ZID, we refer to .ZID, and so on. Let's see that this code works. Didn't have a function prototype. Yes, it compiled. My code must work perfectly. Cool, so I've compiled my code, I've run my code. We can see down here the code. So the code is saying printf, the name is string. It's printed out Andrew, the ZID is Andrew.ZID, it's printed out the ZID. The assignment 1 mark is this double, it's printed out this double here. Is this all good so far? I've made a single struct, I've put some values in it, and then I've printed them out. So let's make a function to do this printing out for us instead. Print student. So let's make a function that'll print out the students, that we don't have to type this code every time we want to print out one student. What should I put in here? What do I put inside the circle brackets for my function? Yeah, it's the things that I'm passing into the function, right? So in this case, what am I passing into this function? Yeah, one struct of type, one student struct called Andrew. I'll give it a more general name because not every student is called Andrew. How many of you are called Andrew, out of interest? It's like the third most common name in CSE, so Daniel is the first most common name, just in case you were wondering. Can I do this? Replace, 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 replace. Cool, so now my print student function takes in a struct called student, and prints out student.name, student.zid, student.assignment1mark. Cool, hopefully this is all good thus far. I need to actually call my function, giving it Andrew, and I need to make a function prototype. Cool. Does it still compile? Oh man. So the problem I'm getting here, my declaration of my struct is down here, but I'm trying to use that struct type in my prototype here. And it's going, I don't know what a struct student is, I'm confused. Extraneous closing brackets. An unnecessary closing bracket. So I do. It's going to compile. Yes, it compiled. Cool, and so it still prints out the struct like we had before. So struct1. Cool, great function, great program names. So let's then look at our struct array function, just to do something with an array of structs. Shh. We will have a break very soon, I promise. Shh. Shh. If I do it louder, you'll be quiet. So down here, I have my array of student structs. So it's of type struct student array called students. And so students square bracket 0 means get the first struct in this array. And then to prove that it's worked, I'm going to call my print student function. Students 1, 1, 1. Okay. Didn't call my function. Cool, so what my program should do now, my main function calls struct array, which is this function down here, which makes the array of student structs, fills out array index 0, prints it out, fills out array index 1, prints it out. And so, in theory, this means it's now called struct1. It does help to use the right file name. Cool, and so I've run my function from the right file this time. It's printed out the name is Andrew B, the ZID is this, the assignment mark 1 is this. assignment 1 mark, the name is Andrew T, the Z80 is this, the assignment 1 mark is this. So does that make sense? I have an array of student structs. I've put values into each of these different array elements, and then I've printed out these arrays, these structs. Is this all good? I highly recommend you pay attention to this bit because this is going to help you with the lab for this week. And if you were paying attention, the lab will be great, and if you weren't, then the lab's going to be really hard, and you're going to wish you'd paid attention. Are there any questions before we have a break? Okay, let's have a break of 10 minutes. Get up and walk around and don't just sit there. It'll be great, I promise. So I've had a request from a student sitting up the back. When everybody keeps talking, it's really hard for them to hear me. So if you want to keep talking during the lecture, then just don't come to the lecture. I mean, I don't miss out if you don't turn up. They don't pay me based on how many people turn up, right? So if you want to sit here and talk and ignore me, please talk at home and ignore me at home. You want to be respectful for the other people, the other students who are trying to learn. And if you're talking to your friend next to you, and then the other students can't hear me and can't learn, then you're being a bit of a bad person. So I got a really good question during the break that I should have explained and have not explained, and will explain now. And also the tablet now works, so thank you to the power of USB chargers. Record, 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 record. Okay, so the question was, if we have a pointer, right, so I have the code int number equals 10, and then int star p equals the address of num. So this means that over here in memory, I have a variable called num, contains the number 10, a variable called p, contains the address of num. Grab a different color. 104. So my variable num has the value 10. My variable p has a value 0x100, which is the address of num. And so this is like saying that p is a variable that points to where num is in memory. So hopefully this is all good so far. This is what we talked about before. But the question was, what happens if we change p by going star p equals 100, no, say 20, compared to saying p equals 20? And so this is a really good question. When we say star p, we mean look at what the address is that's stored inside p. So address 100 in this example. Go to that address and change the value at that address. So in this case, this would make this be 20 rather than 10. So star p equals 20 means go to the variable p, go to the address it stores, which is 0x100, put the value 20 into that address. Star p equals 20. If I compare that to saying p equals 20, I'm saying change the value inside p to be 20. And so p, rather than having 100, now contains 20. And of course, a pointer holds the address of the variable that it points to. So now p is a pointer to the variable and address 20. So way up here in memory, I'll put it over here. Address 20. P now points to whatever is in address 20. It's going to be stuff you can't touch. I guarantee you if you try and do that, it'll be sad. I won't demo that, but you can just believe me. If you try and go p equals 20, set the pointer to point to memory address 20, and then change what's in memory address 20, it's going to go none. Can't do that. So does that make sense? It's a really important distinction to make. Pointers are variables, and their value is the address of what they point to. Is that all good? Are there any questions on that? Did someone just say, what's your password? 123, it's my password. Oh no, it's 126 now, because you've got to change your ZPass every 6 months, and you can't reuse it. So up next, let's play intensity, or at least let's talk about intensity. So, I know it's a very intense game that you can be silent, experience the intensity in silence, make the people up the back actually able to hear me. So for this assignment, I am hoping that you've all read the assignment spec, and I'm sure some of you haven't, because I know that I tell you should start early and you think, oh, Andrew says I should start early, but I'm going to start the week before it's due because I've got better things to do with my life. I understand, I am that student, but speaking from experience, don't be that student. Your life is really stressful. So read the assignment spec and start the assignment. But something that it's important to understand, for this assignment, your task is to write a program to play the game intensity. So it's like if you imagine you're playing with friends. When you play, you have cards in your hand, right? And then you play a card from your hand on the table, and so on. Your job is to play the cards. Your job is not to deal the cards, or to shuffle the cards, or anything like that. Your job is just to say, okay, here's the information you've given me. I'm going to take this information, I'm going to discard the card 23. So then you print out 23. So the intensity referee does all of that stuff for you. You just have to write something to play the game. In terms of how the input works and how the output works, all of the input is given over standard input, or stdin, or scanf. And all of the output that you give is done over standard output, or printf. So I'll have a look at the assignment spec. Probably easiest to go from here. Assignments, assignment 2, view in browser. And I changed the layout of this page, I think, over the weekend. Sometime it's been, I've had a whole week of weekend with Quiet Week, but I've changed the format so now you can click on each of these things to see what's going on and it'll all be structured well. So I am going to assume you've all read the rules and you understand the rules, and I'm also going to tell you the rules really briefly because I'm nice like that. It's a card game. There are 40 cards in the game. You are given 10 cards. There are 4 players. Each player has 10 cards. In the game, for each of the rounds, you want to discard a card. How many of you do not know the rules of intensity? And if I don't tell you the rules, you're going to not understand anything I say. Okay, either you're not admitting it or you guys can read the spec really quickly. But basically, in this game, you scan in information about the previous rounds that have happened. You then process that information and think, oh, given all these things that have happened, I've got these cards in my hand, they played this card last turn, and so on. I am going to print this card. I'm going to play this card, and so you print that out. And to understand the rules, one of the tutors has made a video. You should very definitely watch. It's very useful. So there's showing a sample game and showing how all the plays work. So I do highly recommend. In terms of the assignment, your job is to write a C program that will play the game. So there are effectively 3 steps to do. The first step is to print your player name. So if you are called with the number 0 saying to print the player name, you should print out the player name. Cool, that's a good step to start with. The second thing you'll be asked to do is to select the cards to discard. And the third one is to select which card to play. In terms of selecting cards to discard, the way the rules of the game work, at the start of the game, you have 10 cards. You then decide which 3 of those you want to give to the person on your left, and then you get 3 from the person on your right. In terms of how the input for this works, the first number is 1, so the main function calls your choose card to discard function. You are then given 10 numbers, which are the cards in your hand. So for this step, you should make an array that's 10 big, scan in those 10 numbers, and then decide which one to discard. Sorry, which 3 to discard. And then playing a card, you're given all of this information, all of this stuff here you've got to make sense of. It's really confusing, who knows? Thankfully, we break down what each of the things mean. So when your AI is asked to play a card, you have to scan in all of this information. This is like 1 round. So this is your AI is being asked to play 1 card. The information you're given, the number of cards in your hand, the number of cards played so far this round, your table position, I think, the cards in your hand, the cards that were played, the cards that have been played in the game, the cards you discarded and received. Read through those to see what they mean, but effectively, like the 9 here means there are 9 cards in your hand, And these are the 9 numbers, which are the 9 cards in your hand. I believe we added to the spec initial code. So we've added comments telling you all of this. So in the choose discards function, you want to add code to read the cards of your hand into an array using scanf, and then add code to choose the cards to discard and print them out. So it'll be scanf into an array and then printf some 3 numbers that are from that array of your hand. When choosing a card to play, this is telling you all of the input we give you. There's the 3 numbers, there's the cards in your hand, the cards previously played, blah, 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 blah. So read through the spec, but we've told you scan and this, scan and this, scan and this. You then need to play a card that's a legal card to play. So make a move that is a valid move that you are allowed to make. The rules for that are all in here. Somewhere it explains the things that are and are not valid to do, but I've also made a diagram for you to look at if I haven't lost my cards, which I will look at next. So if you're confused about the rules, read through the rules and then also look at this diagram. In terms of what card is valid to play, if you're not playing first in a round, if you have a card with a matching digit, you've got to play that card, otherwise you can play any card. If you are playing the first card, if a calf hasn't been played and you have non-calf cards played, and so on. Read the rules, look at the picture, and then if you're still confused, ask on the forum. But hopefully this will be enough to non-confuse you. But an important thing to understand about the AI is that it is what we call stateless. Your AI comes to life for one single move. It is asked, please do one thing, which is print your player name. Please do one thing, which is decide which of these cards in your hand you want to play. So your program is run once for each move, effectively. So it's run 12 times, I think. So for each move in the round, for each card you play, and so on, you need to read the input, think about what to do, and then print out your decision that you've made. The intensity referee is the thing that runs the game. You can access it with 1511 intensity_referee. You can run your AI against it by giving it the file name of your code. You can play it interactively, so you can, as a human, play the moves by using -I. And so, let's have a look at this. I'm going to try really hard to not accidentally show you my code. Okay, I'm not going to look at any code. Intensity referee, intensity.c. So this is going to play a game with my AI competing against the human players. Sorry, competing against the system players. So you can see all these rounds are happening. Each round, my player decides what to do. Oh, look at one. Yay. So for example, at the start of the game, my thing was given these cards. It discarded these cards. On the first round, it played this card, and so on and so on. So you can run your AI with this code, and then you can see how your AI does. These players all make random valid moves, so it's quite easy to win against them once you've got an AI that has any strategy. And if your AI just reaches the point where it can play random legal moves, you get any legal move, you get 60% for the assignment. So you can pass the assignment by just playing a valid card. That's all you need to do. You can also play an interactive game of intensity. Shh. And so I highly recommend do this a couple of times so that you get used to playing the game. So in this case, you start out by choosing your discards. So like I might decide to discard 48, 35, 39. And so now I've discarded these cards. These are my new cards. I've got to pick a card to play. Play the 44. You can see this is the cards that the other players have played. Lulu played the 47, so she got the buffalo and she got the penalty points. Ha ha ha. And so we can see this round started. I've got to choose a card to play. I'll play 23, and so on. So you can use this to actually play the game. Shh. I also highly recommend actually playing the game with cards. I've made up 4 decks of cards if you find me in a lab sometime when you want to play. Otherwise, you can just take a normal deck of cards and just take the 1 to 10 of each suit and write the numbers on them. If you can find 3 friends, you can play a game of intensity together. I haven't been able to do that with friends yet. But play the game, use the interactive player to play the game to understand the rules. Use the interactive player to test your program to see if it works. Shh. and do start the assignment. I think that was all the things I had to say there. And then once you've read the assignment spec and once you've read about what's a valid card to play, look at this picture as well, and then hopefully you will understand it entirely. Okay, are there any questions about the assignment? Is it a question? Yes. But that's a good question. In terms of the C syntax that you need to use for the assignment, you need to use arrays. You need to use functions. You need to use if statements. You need to use scanf and printf. That's all. You don't need malloc. You don't need structs. You don't need anything else. Don't need pointers. You only need arrays. You can use other features if you want. If you look in the style guide, it says do not use things like global variables or gotos or so on. Don't use those. It's bad. It's really bad. Don't do them. But you can use any functions in the C standard library. You can use any functions we've learned in the course. You don't need them, but you can use them. Is there a question over there?
Yes. Do you want us to create our own additional functions? Is that what the requirement is, or we don't need to do that?
So the question was, is it a requirement that you create your own additional functions? We have not written down you must make additional functions. If you don't make additional functions, you'll probably get 0 for style. It is impossible to write a good solution that uses only the one function, only the one play card function, and it's 10,000 lines long. That is not good written code. That is not good for a human to understand. So we don't explicitly say it because we expect that you will know it by now. To write good code, have lots of functions. Cool. It's a good question. Yes? Mm-hmm. If I understood your question, if I say you just have to print them out, does that answer your question? If I say that you just have to print them out, does that answer your question? Yeah. Okay, so the question was, for the assignment, like you scan the values into the array, for example, but then when you discard 3 cards, do you have to actually remove them from the array or just print them out? You just have to print them out. The referee doesn't look at your code, it just looks at the output from your code. Yep. It only looks at the printf. It gives you stuff to scanf, and you printf, and it looks at the printfs. Cool. Are there any other questions? Okay. I heard someone say, oh, I'm way complicating this. Yes, most of the people who are confused are trying to solve a really hard problem. You don't have to solve a really hard problem. You don't have to generate the cards. You don't have to shuffle the cards. You just have to scan an input and print out output. And if you do have more questions, you can post them on the course forum. You should look on the course forum to read questions first, because there are lots and lots of answers. And then if it's still not answered, you can ask the question there. Okay. So let's move on to a new topic that's not a new topic, because all of the topics from now on are just new things with existing things. What's up? You're running away? Okay. Goodbye, tutor. We'll miss you. So, looking at memory. So I know that Jashank talked about this. I'm going to talk about it again. I'm sorry there's no bold here. I should have put some bold in. But an important thing to understand is in your functions, when you make variables in a function, they live in the memory for that function. They live in that box of memory that I draw, and I'm going to draw it in here because I can. HDMI, laptop. Okay, so when we have a function, int foo, cool, it's a function. I don't know, an age equals 100. So we have our function. It has memory for this function. Inside the memory for this function, it has the variables inside this function. So I is 10, age is 100. When the function has returned, when the function is no longer running, this memory is gone. The things in this memory, you can't talk about them still. You can return a value because that will copy that value and give it to the function that called you. But you can't access these variables anymore. Oh, I reached my step goal. If you return an address, if you have a pointer, you return the address of a variable that's in a function, you can't access that variable again afterwards. I mean, you can, but it won't have what you expect in it. It's like, so one of the things people try to do is return an array from a function. They go, can I make an array in my function, and then return that array, and then the other function has that array, right? So let's do that. Int main. Let's make that smaller. Inside main, we have some memory. Int star foo. So inside this function, I make an array, make it be of size 10, everything's good. I return the array. And so here is a memory for my function foo. I make an array. It's 10 big. That is completely 10 items. When I return array, remember I said arrays are pointers. So when I have the variable array, that actually refers to the address of this array. Let me do that in a different color. Oh, darn. So if we say this address is 0x123, when we return the array in this function, int star x equals foo, our function foo is going to make an array inside it, return the array, so return the address of that array to the main function. So the main function has a variable called x, which contains the address of this array down here. I've said int star x equals this. Remember how I said pointers, arrays are just pointers? So you can make a pointer to an array and then treat that pointer as an array. So what this is saying, this variable x in here is a pointer to this thing here in memory. So conceptually, does this make sense? Like we were talking about before, pointers contain the address of something in memory, and so they're effectively pointing to that address in memory. So what happens here, in this function, in foo, we make an array, we return the array, and then the function is over, the function is ended. The memory, this is an important bit, the memory in that function is reused by whatever happens to run next, whatever function we call next. So we can still point to this array, we can still try and access the array, it'll be valid to access, but it won't contain what it used to contain. When the function returns, that memory can be reused for something else in the program. It's sort of like how I can give you guys all addresses and I can reference the people in each address. So I can say in, I don't know, seat number 12 is this person here. But then if I try to access the person in seat 12 in 2 hours' time, it's a different person, right? You guys have all left, new people have come in, the address is still there, the memory location is still there, but it has different contents. Does that make sense? Cool, that's one of the key things to get. I think I have code for this next. I sort of have code for this. So this is what we call the lifetime of a function, sorry, of a variable. The variable will cease to exist once the function ends. Like the memory location is still there, but the contents are not what you expect it to be. But sometimes we need it to stick around for longer, right? We need to be able to do things to an array inside a function, or various other things. And so there are two options for this, two ways we can do this. We can make the array, for example, in like a parent function. So make an array in main, pass that array to some other function that does things to the array. Because the array lives in main's memory, it's safe there. It doesn't go away when the function returns. More on that in a second. Or we can dynamically allocate memory using malloc, and again, more on that in a second. So we can make a parent function, by which I mean, if you imagine like the function calls as a tree, you've got a function that calls this function, it calls this function, it calls this function. The function that calls the other functions, I'm going to draw a picture rather than just trying to wave my hands. Work much better that way. So in our function foo here, we have some memory, we have an array, make array, Then we call our function bar with our array. So then in our function bar, we have, remember, arrays are pointers to arrays, and array simultaneously is a pointer to itself, because that completely makes sense. Sorry, foo and bar are the name of my functions, because I couldn't think of better names. They're like common programming things to be used. So array is a pointer to this memory here. And so the problem we have, right, is that when this function ends, when we hit the badly drawn return, the function is gone. The memory is still there, but the stuff inside the memory is gone. So you can see we can make changes to this function here inside our function that I've just scribbled out. And that's fine, because this memory will continue to exist. We can't make things in here, we can't make an array in here, and then try and give the function foo a pointer to this array, because when the function bar ends, that array is gone. But you can see whatever functions I call from inside foo will still exist, and so this array will still exist. And so if I want to use an array, I can make it in the main function or some function, and then pass it into all the functions that calls. Does that make sense? Cool, thumbs up. And I'll play with code for this in a bit. The other thing we can do is we can dynamically allocate memory. Actually, I'll go through this to show the syntax again. So in foo here, we are making the array inside foo. We're passing that into the function bar, and then we're printing out the first element. And then in bar, we're just setting the first element. So the array is made inside here, and we give it to this function. We can also dynamically allocate memory, which magical words for make memory somewhere else that doesn't go away. And so in this case, rather than passing in the array to bar, in bar I'm making the array. So remember I said arrays are pointers, hand wavy, it'll make sense. But I can say int star array equals malloc, which means give me some memory that's this much memory, and then make array be a pointer to it. And then I totally actually meant to make this be a function that returns something. My bad. Pretend that I actually got this right. So this actually returns an int star, and then I return array at the end. And so then I'm saying int star array equals the thing that bar gives me. And so I'll draw a picture over here. Inside bar, I make a pointer called array. But because it's a pointer, it's just one number. It's the address of this memory that I get from malloc. And so let's say malloc gives me some memory over here. Cool, here's your array you asked for. Here we go. So it points to some memory over there. That's safe. It's not going to get destroyed by our stuff here. And then when we return this number, when we return array, we're returning the contents of this variable, which is the address that it points to. So we're saying this is at memory address 1, 2, 3, 4, 5, 6. And so when we return, I really wish I'd actually gotten this right. I'm sorry. When I have the line that's invisible here that says return array, we're giving this number here, the number that is the address, back to this function foo. So array here is this address. I'm just going to move that over there. Oh yeah, it's totally readable. So because the memory we allocated with malloc is all the way over here somewhere safe, when our function bar goes away, this memory over here is still safe. So does this make sense? This is a way that we can have memory that we make inside bar, inside our other function, and then we give to the function that called us. The reason we can do this is because we're not making the memory in our function. We're making it in the magical memory over there somewhere called the heap. And that memory will stay there. That memory isn't going to go anywhere. Does it make sense conceptually? Cool. I don't remember what else I put in the next slide. That might actually have been all of the content. Okay, so let's write some code. Let's write the non-broken code for a start. Let's call this one allocate memory.c. Cool, and so this is what the code was going to look like if I'd written it properly. In our function foo, we make ourselves a pointer to an int, we call it array, and we make it be equal to the return value from this function bar. This function bar allocates some memory using malloc. Malloc is a function that makes some memory somewhere up over here in the cloud and gives us back a pointer to that memory. So it will set aside some amount of memory for us and say, here's where that memory is that you asked for. Like the memory of the size you asked for, it's over there, here's how you get to it. I can then set a value in this memory to be something, so I can say array 0 equals 1, 2, 3. This is, I'll draw a comment here. So malloc has effectively given me to do a massive block of memory like this. And each of these, how do I describe this? It's effectively, I've asked it to give me size number of things of type int. So if size is 100, I've told it to give me like 100 times the space it takes for an int. And so this means that I can now treat it like an array. I can treat it like I have 100, I really don't want to write 100 things here. Right, so I can treat it like it's given me an array of size 100. It's given me the memory that is of size however much we asked for times the space to fit one int. And so then I can say array 0, and that refers to the first int worth of memory inside this chunk of memory I've been given. And then I can return that back to this function here. Does that make sense? Let's run this and see if it works. It probably won't. I've probably forgotten my function prototypes again. At least I remembered this time. I also need a hash include. Man, you're asking for so much. Cool, didn't show you my code. Good work. My code's fantastic. Literally the best. That's why I'm like bottom on the leaderboard. T2C0, allocate memory. Allocate memory.c. I've forgotten a hash include. Did you forget to hash include stdlib? When you use malloc, malloc is found inside standardlib.h. And so conveniently G2C has told me, hey, did you forget to hash include stdlib.h? Yes, I did. I know that you told me, but I was just going to let G2C remind me. That one. Cool, and so now I can use the function malloc because malloc is inside this. I have to define size. You guys asked for so much. Let's make it be 100. What have I forgotten now? Oh, nothing, it works. Beautiful, code must be perfect. So I can run my I can run my program, could allocate memory. What this program does, main function just calls a function foo. Foo gives me a pointer to an array, which is equal to the return value from bar. Bar down here allocates some memory, sets a value, and then returns it. And so then foo gets the address of this memory it's given us and prints out the 0th array element. So this should printf 1, 2, 3. It printed out 1, 2, 3. Let's put a new line in this so it looks more impressive. Cool, so it has printed out 1, 2, 3, and you're going, Andrew, I could have just written printf 1, 2, 3 in the main function. This sucks. What are you doing this for? Let's compare this to, oh, do you have a question? So it has this bit changed and this bit changed because I made a mistake. Shall I fix it now and then update it? Return. Okay, I think if I go this one. Are you guys making UniWide be slow again? Okay, and now if I go back to my slides. Oh, look at that, the code was never broken. The code is just like it should have been. Yep, no, my bad. And so that should be exactly the same code. I returned the function name. Oh my god. So the problem here is that I've returned the function rather than the variable inside the function because stressed because my slides are broken and I'm giving a lecture. Async. Come on, computer, you can do it. Cool. Look, no, I never returned bar. What are you guys talking about? It's code's perfectly fine. But yes, thank you for pointing that out. So, looking back at this code. No, I was going to copy this other code. What they said. Back. This one here. Okay. So then this is the code from the, is that a question? So then this is the code from the slide before about making an array and passing the array into that function. So, stepping through this again. This time I'm making an array inside foo. So here is my function memory, the memory for my function. Here is the array. So the memory actually exists. The memory actually exists inside this function here. I'm then calling the function bar with this array. So I'm saying, hey bar, let's say that's at address 123. You can get to this array at address 0x123. And so inside bar, I'm saying set array element 0 to be 123. I should be using different numbers. 20. And so when I say array 0 equals 20, what I'm saying is go to this array in the function foo, which is at this address here, and set the first array element to be 20. And so then when I print it out up here, it's going to print out 20, hopefully. Array.c. Man, got my function prototype wrong. Does anyone else always get function prototypes wrong? Is it just me? Some other people do. I'm glad it's not just me. I'm glad we're all bad at computers. Printf, new line. Compile, run. Cool. So this code has, again, printed out the number 20. Wow, it's so impressive, Andrew. But it's done this by making an array inside the function foo, passing that array into the function bar, and changing it in this function here. And so people have asked me, like, hey, Andrew, for the assignment, he said assignment, let's pay attention. Hey, Andrew, for the assignment, how do I, can I return an array from my function that gets the input, or do I have to do it in one function? The answer is you can make arrays in a function, give those arrays to another function to get those to set the values, so it's kind of the input or whatever you want to do. And then that will change the memory that's in this function here. Does that make sense? And then in comparison, zoom out, copy. Cool, and then so for my one where I allocated the memory, I've said malloc me some stuff. That's going to give me some memory up here in the green cloud and give me a pointer to it. Come on. Cool. And so this one here, I've allocated the memory from inside the bar function, which has made me some memory up in the cloud using malloc, giving me the pointer for that. And then when I returned that pointer from bar into foo, foo now has the pointer to this memory here. Does that make sense? Yes. So can you say that like twice as loud? How do you what the memory? Oh, how do you free the memory? That's a very good question, and I totally forgot about that. So, shh. I'm sure you've all heard of Newton's third law of memory management, which is for every malloc, there must be an equal and opposite free. So, very good. Forgot about that, my bad. So, in this code, I have made one malloc. I have allocated memory once, this memory here. That memory will exist in this cloud forever. Forever and ever and ever. It will exist there for the rest of eternity, unless I free it. To free the memory, can anyone guess how I free memory? I type free. Wow, it's amazing people. And so I type free, the function free, and give it this pointer. Give it the memory that it should free. Give it the address of that memory that it should free. And so what this will do is this will tell malloc, tell the cloud, hey, this memory, you don't need it anymore. I'm finished with it. You can give it to someone else. Now the cloud is nice and pristine again. Why does this matter? Why do we care if we free our memory? How many of you use Google Chrome? How many of you have to restart Google Chrome because you run out of memory and it uses up all your memory? Yeah, everybody. So when you have a program that is a big program that runs for a long time, if that allocates memory and doesn't free it, then over time it'll use more and more and more memory. Like I'm sure Chrome does free its memory, it does try very hard. But if you've ever seen programs where you restart the program and then your memory's free again, that's because they're allocating memory and they're not freeing it afterwards. So you should be a good person, free the memory when you're no longer using it, so that something else can use it. Cool. Are there any other questions? That was a good question. Yes? Right, so as the question for this, how do I know it's an array? Like, how can I do this? This one here? Cool, yeah. So, and that's a very good question. The question was, I'll just answer it and then you can get the question as we go. So if I have an array that I make with square brackets, one more minute and then we'll be done. If I make an array with square brackets, I'm saying make me 10 ints worth of space in this function's memory. And then array is effectively a pointer to that memory inside this function. When I say int star array equals malloc memory, the memory is over here in the malloc place, and so array is a pointer to this memory here. So it's the same thing except instead of the memory being in the function, it's up here in the cloud of malloc. Does that make sense? Yep, so square brackets makes an array inside your function, and malloc gives you memory that you can use as an array inside the cloud. Hang on. What's... I'm sorry, I can't hear you. Do you want to ask me at the end? Cool, so that is our time up.